this can be very important because if you know where you've got meltwater coming out, basal meltwater coming out, then you know which glaciers are warm-bedded and which are cold-bedded. This is quite important for working out ice dynamics and looking at which areas of Peninsula or Antarctica as a whole are melting faster than others. You could possibly monitor change by seeing if this changes over time. If you get meltwater coming down in different areas, it could be very useful for looking at how glaciers are advancing or accelerating. So there's quite a few possibilities. And we're looking this year to take some samples of this glacial suspended sediment in the water column off the South Shetlands or the South Orkney Islands, and take synoptic satellite images, probably QuickBird or WorldView 2 images, so that we can calibrate what we're seeing on the satellites to what we've got in the actual water column. Okay, so to conclude, there are also exciting new developments in polar imaging and Antarctic imaging. I've told you about. I've only really got about some of the case studies we're doing in mapping geographic information center here. There are lots of other things that Hamish might talk about later. I know he's giving us some talk from glaciology point of view of some new developments at BAS. And of course there'll be lots and lots of new developments if you come to the conference later this week. I can't talk about all of those, but at least I hope I've given you some good examples. Thank you very much.
We should have time for a few questions as well. If no one else has one, I'll start off. How much does the how much does the lithology of the area impact how you see these sediment plumes? Or do you know yet?
Sure, probably if it's soft lithology, we're going to get it may well change, but that's something that, because this is not really, as far as I'm aware, not really been looked at before, especially in Antarctica. Not entirely sure, but there'll be lots and lots of different things that we're going to have to think about, weather, currents, lots of things. So we're not sure. This is a very, very new study, and we're only just starting to look into the implications. But I can't tell you. Hopefully, in a couple of years' time, I'll be coming back and be able to answer some of those questions.
Yeah, I've got a question regarding your vegetation studies with NDVI. Because especially when there's only like very little vegetation, not dense, you get a lot of influence from the soil.
Yes.
Have you considered trying SABIs, those soil-adjusted vegetation indices?
We did try that, but the NDVI values were very, very low, and it didn't seem to work to start. The effort we put into it didn't seem to work. What we did find was that in Antarctica, the soil is very, very minerogenic. There's hardly any actual organic matter in it at all. It's usually the organic matter that affects the NDVI values. Now, there's no, if you go to most of Antarctica, because the vegetation is so, the maps are so small that there's hardly any heat or anything like that. Also, we did find that some of the rock influences, the rock type influences the actual NDVI values. We came with a couple of, because we're looking really on the cusp of what can be visible, we found that a couple of rock types actually take the values over there, and we had to put in spectral masks to actually counteract some of the rock types that were there. But the soil itself, because it's got very, very little actual organic matter, and it didn't make that much of a difference.
I was really intrigued with your predictions on vegetative changes in the warming period. Is there any speculation of what kind of animals or how that will impact Antarctica? That is, what will invasive species, you might say, or other species from other areas? Any speculation?
Yes. Well, invasive species are a real big concern at the moment. We've, as I said, we've just found that we've got a third species of herbaceous plant that's now indigenous in some of the South Shetland Islands. We've got a new species of midge that's been brought in recently, and again around Fildes Peninsula over the last couple of years. That's now indigenous as well. So it's hard to know, and we think most of it's been brought in either by people. We don't think that many of these are natural things. They're being brought in by tourists or by the scientists. So it's hard to know. But the problem there is also knowing whether it is, because of course you're much likely to find these invasive species where people go. Because if you go to so it's hard to differentiate between how they're being brought in, what is the actual mechanism of being brought in. Now, whether some predictions on invasive species actually forcing other species out and out-competing them, and that might happen as well. So we may find that we lose certain species from other areas. That's certainly happening with penguins. We're finding that the chinstrap penguin is being forced further and further south as other penguin species like gentoos expand. So the Adelie penguin chinstrap is being forced further south. So that might happen with vegetation as well.
One other question. This data, the high resolution and hyperspectral data, looks really cool, but it also looks really expensive. Do you know of any easier ways for, say, early career researchers who might not have as many resources to be able to get their hands on this sort of data?
We're very lucky because we have collaborations with people like the Antarctic Geospatial Information Centre, and it's useful to often be in collaboration with some Americans who can get the data much cheaper than you can. So if I give you a tip, it's like collaborate with some Americans who can get the data really cheap. But on the other hand, some of the data is available for you. So the quick looks are very, very useful. For the hyperspectral data, we were lucky in that case because the ITRIS people, the Canadian group ITRIS, wanted actually to trial their instruments in Antarctica, and we were happy to allow them to trial it, and we just dreamt up the excuse to get them southward. So that was very lucky from our point of view. I'm not quite sure how you go about getting cheap hyperspectral data, I'm afraid.
Fair enough.